Hello coders, I welcome you all. In this video, we are going to discuss very important part of MLOps, the model registry, which is midpoint in MLOps. First, we will cover some theoretical background for a better understanding, and then we will move on to the practical part of model registration. So if we talk about MLOps, MLOps is made up of machine learning and operations that you can see over here. Machine learning plus operations is equal to MLOps. So if you watch this video up to the end, you will understand how the ML model lifecycle typically works in the industry. Now let's first talk about model registry. The model registry serves as the midpoint between machine learning and operations that you can see over here. Machine learning, operations, and midpoint is model registry. So I'm taking this example so you can understand the need of model registry. So as you know, we version the code using Git or GitHub, right? And version the data using DVC, data version control. Similarly, we can maintain versions of models using model registry. Hope all of you are clear with this. The need of model registry. We can maintain versions of models using a model registry, which is almost similar to GitHub and DVC. Hope all of you are clear with this. Now let's move on. So now let's first understand what is MLflow model registry. The MLflow model registry is like a library for your machine learning models. It helps you keep track of different versions of your models. Know which ones are ready for use like in production, and even helps you switch between them when needed. Now the next question is, why use it? Imagine you have built a few models for predicting house prices. You want to keep track of which model performed best, which one is currently being used in your application, and you can easily swap out models if you find a better one. Now you can understand the need of model registry. The model registry helps you manage all this. So as we discussed earlier, the model registry serves as the midpoint between machine learning and operations. So now let's first discuss machine learning, this part. So data scientists and ML engineers focus on developing, training, and tuning machine learning models. They experiment with different algorithms, hyperparameters, and data processing techniques to create the best possible model. Now let's discuss model registry. Once a model is developed, it is registered in the MLflow model registry. This step marks the transition from experimentation to more controlled production ready environment. So you can see this is the midpoint. Now next, operations. The operations team can then take over, deploying the registered model into production environments. They manage the life cycle of these models, including scaling, monitoring, and updating them as needed. So before we start our session on model registry, let's first understand the workflow of how the ML model lifecycle often works in industry. This will help you to understand the need of model registry. As you can see here, different steps of ML model lifecycle: model development, model registration, model deployment, and monitoring and retraining. So let's start with model development. As you can see here, data scientists and ML engineers experiment with different models, hyperparameters, and the techniques to find the best possible model. They typically evaluate models with metrics like accuracy, precision, recall, and F1 score to choose the best performing model. Then the next stage will come, which is model registration, that we are going to discuss in this particular video. So once the best model is identified, it is registered in the model registry. The model registry serves as a centralized system to manage the versions of models, including metadata, stage transitions like model in the staging area, model in the production area, and model lineage. Don't you worry, we will discuss this all practically. Model lineage tracks model's journey from creation to deployment, indicating data sources, training, versions, and performance. It helps ensure transparency and reproducibility by documenting each stage of the model's lifecycle. So hope all of you are clear with two stages of ML model lifecycle: model development and model registration. Now let's move to next stage, model deployment. The operations team or MLOps engineers then take the model from the registry that we have registered over here in this particular stage, model registration, and handle the deployment process. This step involves putting the model into production, where it starts making prediction on live data. Deployment can be done using APIs, containers, or other applications, depending on the specific requirements and use case. So we have completed 3 stages of ML model lifecycle: model development, model registration, and model deployment. Now next stage, monitoring and retraining. After deployment, the model's performance is monitored. If there is drift in model performance or changes in data patterns, the model may be retrained or redeployed. So now you can see workflow of how the ML model lifecycle often works in industry. So in this video, we are going to discuss this particular step, model registration, but also you will understand the importance of model deployment, monitoring and retraining as well. So this is very important video. Please watch up to the end. I'm sure you will learn something. So now in MLflow, models go through different stages to manage their lifecycle effectively. I'm repeating, in MLflow, models go through different stages to manage their lifecycle effectively. Let's discuss this. You can see over here, model lifecycle management with model registry. And here we are going to take this example, water potability prediction. So as I said, in MLflow, models go through different stages to manage their lifecycle effectively. So a model in MLflow can be in one of the following stages at any given time: development, staging, production, and archived. Let's discuss one by one. This is very important. So now let's start with development. So the main goal of model development is to create and refine the model, which we achieved so far using experiment tracking and other techniques, right? Now let's move to next stage of model lifecycle, which is staging, also called as testing phase of the model. Let's take the example of water potability prediction. So the water potability model is first tested with historical data in the staging phase. As I said, this is testing phase. It is registered in MLflow as staging to track its performance and ensure it meets the required standards before moving to production. This is testing phase. So after this particular stage, staging or testing, model moves to the next stage, production. Once the model is validated, the model is deployed in the production phase. It is marked as production in MLflow and used to evaluate real-time water samples. The model's performance is actively monitored to ensure it operates effectively. After production, model may be in archived state, which is when a new model replaces the old one. The previous model is moved to the archived stage. In MLflow, it is kept for historical reference or compliance purposes. Again, that we will discuss shortly. I will show you this all practically. At the end, we can conclude that model registry helps manage and track models throughout their life cycle, ensuring they are reliable, well documented, and properly handled. So these are the model lifecycle stages that you can see over here. As I said earlier many times, we will discuss this all practically. So these are the model stages that you can see over here. Development, staging means testing, production, and archived. Now let's move on. So throughout this video, we have to assume that we are working in collaborative environment. When the stage changes, everyone can see the current stage of the model, whether model is in development phase or in staging phase or in production or in archived stage. Means our team members can see the current stage of the model. So I can understand first time it is very difficult to understand all of this. But once we complete the practical part, I'm sure you will understand everything. So let's move on to the practical part. Let's jump to VS Code. So we are going to use the same code that we updated in the last video that you can see over here. So the only changes I have made in this: prepare training data, and also inside prepare test data. So in place of this numpy, just I have converted this into pandas data frame, independent variables and dependent variable of training data. Same I have done for test data as well. In place of this numpy array, I have converted into pandas data frame, independent variables of test data and dependent variable of test data. These are the only changes I have made in our code. Otherwise, the code is exactly same that we have updated in the last video for hyperparameter tuning that you can see over here. And as you know, we have logged the base parameters along with all other combinations that you can see over here, right? Now let's open command prompt. Let's create new directory with name model underscore registry. You can use any other name as well. Let's move inside this particular directory and let's open VS Code from here. Let's create new file water underscore portability dot file. Let's select this code. Let's copy this code and let's paste our code over here. Now let's save our file. Let's open new terminal and let's first open MLflow UI using this particular command MLflow UI. You can see MLflow serving on this particular URI. Let's click follow link. You can see over here our MLflow GUI. Let's back to VS Code. Let's open new cell and let's run this code. It will take some time, we have to wait. You can see base parameters found and estimators 1000 and max depth 20, right? And here you can see accuracy, precision, recall and F1 score means all done. You can see we can run our code properly. Let's move to MLflow GUI and let's refresh this page. You can see over here. New experiment has been created. You can see this is parent run and child runs that you can see over here. And this is our best run, which is parent run, right? So let's move inside this parent run. And you can see over here, logged models. So we have logged this particular model, right? Now we are going to register this particular model inside MLflow model registry. First, let's click on artifacts. And here you can see model schema, which is currently absent. And you can see model schema, input and output schema for your model. Currently, it is not displaying model schema. So first of all, let's add the model signature. When we will add model signature, it will display model schema over here, which is input and output schema for our model. So now let's move to VS Code. So let's move down and you can see here we have logged our model. So here we will create signature for our model. Before that, we have to import from MLflow.models. We have to import infer underscore signature. Let's save our code. Let's move down and here infer underscore signature. And here we have to provide xtest input to our model and random underscore search dot based underscore estimator underscore that we found earlier. Our based estimator means our based model and predict x underscore test, which is input to our model and output from our model, which is prediction. And let's assign it to one variable signature. You can write any. Let's save our code. And here inside log underscore model, we have to provide one argument. Signature is equal to signature, this one that we have created, right? Now let's save our file and we have to rerun our code. Let's clear this and let's rerun our code with model signature. You can see our code is running. We have to wait. It will take some time for hyperparameter tuning that you know. You can see base parameters found. You can see this particular type error. I think there is some spelling mistake. So problem is over here in this parameter. Let's change it to signature. And in place of this variable, let's change it to sign. And here as well. Let's save our code. And now let's rerun our code. So you can see Now we can run our code successfully. You can see accuracy, precision, recall, and F1 score. For this particular experiment, let's move to our GUI of MLflow. Let's refresh this. Let's move over here and you can see new run. You can see parent run and child runs. And as you know, our parent run is our best model, right? So let's click on this. So you can see we have logged this particular model, right? Let's click over here, logged models. You can see each and every information about our models like code, requirements, ML model, conda.yaml, model.pkl and all, right? And now you can see model schema as well because we have added model signature. That's why it is showing this model schema, input and output schema for our model that you can see over here. Let's move over here and you can see parent run and child runs. As you know, our parent run is the best model. So we are going to register this particular model in the model registry of MLflow, which is our best model, right? So please remember there are two ways to add a model to the model registry of MLflow. First, using MLflow GUI or by writing code. We are going to discuss both the methods, but let's start with MLflow GUI. So now let's add our best model to the model registry of MLflow using GUI first. So you can see here register model. Let's click over here and here you can see create new model. Also you can change the version of the model if model is already registered. But here we are going to register our model for the first time. So we have to click over here, create new model. You can give any name. Let's give water underscore portability underscore RF. Let's click on this particular button, register. You can see over here, water underscore portability underscore RF dot v1, which is automatically added by MLflow, version 1 of our model. So you can see this is the first version of our model that just we have registered in the MLflow model registry. So now you can see experiments, this particular tab that we have discussed earlier. Now let's click on models. You can see over here. Now you can see the different stages of model lifecycle, staging and production. Let's click on version 1 and here different stages, and current stage is none, means model in development phase. And you can see staging, production and archived. These are the different stages of model lifecycle, right? So please remember current stage is none, which means the model is in the development stage. Now suppose, assume that if this model has a problem, we can go back and check the details about it from here, source run. Let's click over here and you can see code and we can debug the code as well. Now you can see the advantage of using model registry. Now let's back to models and version 1 and we are going to change the stage of the model. Let's assume that development has been completed. We need to move our model to the next stage, which is staging. Staging means testing. In this stage, the model will be tested by testers. So we have to click over here. Let's click here, transition to staging. Here you can see transition existing staging model version to archive, but we don't have any other previous version of the model, right? If we keep as it is, it will move existing model which is in staging to archive, but currently we don't have any model. Let's remove this click and press OK. Let's move over here, register model. You can see over here. Now currently our model inside staging stage, which means testing stage. In this stage, the model will be tested by testers. Now let's assume that our model has passed every stage of testing. Now we need to change the stage to production. So let's click here, and as we assume that our model has passed every stage of testing, let's move to production. Currently we don't have any other previous version of our model. So let's remove this tick and let's press OK. Again, let's click on registered model. You can see over here. Now our model inside production stage. So now MLOps engineers will take over and handle the remaining tasks with the model now in production. In our case, version 1, this particular model. So now let's assume that for whatever reason, the model performance of our model has degraded. Like here, after deployment, the model's performance is monitored. If there is drift in model performance or changes in data patterns, the model may be retrained and redeployed, right? So again, we assume that for whatever reason, the performance of our model has degraded. So we have to build a new model, right? So let's move to our code and let's do some changes. So here I'm changing max depth like this. Let's save our code. Let's clear this and we have to rerun our code. Again, we have to wait. It will take some time because we are using hyperparameter tuning. As you can see, we can run our experiment successfully. You can see accuracy, precision, recall, and F1 score. Let's move to GUI. Let's refresh this page. Let's move to experiment. And you can see over here, new run has been created. This is our parent run that you can see over here and child runs. And again, we assume that this new model is better than previous one. Now we want this model to be in production. So let's register this new model first. Let's click over here, logged models. Let's click over here and again, let's click register model. Now here is main part. Please concentrate over here. We can create new model. It will create new model with version 1. But we want to upgrade the existing version of the model. So we have to select this. Please remember this. The model will be registered as a new version of water_potability_RF that you can see over here. And we want exactly this. Let's press register. Now let's move to models. And as you can see, latest version 2. And currently we have version 1 in the production. Let's click here to version 2. And you can see for every model, even for version 1 and version 2, we can add description. Water, potability, prediction, version 2. Let's save description for this particular version. Also, we can add tag as well, like author, data, thinkers. Let's add. So for particular version, we can add description and tags like this. Same we can do for version 1 as well. Let's move to register models. Again, let's click on version 2. And you can see over here, current stage of version 2 is none. Means currently it is in development phase. So first, let's move this particular version 2 to staging stage. So transition existing staging model version to archive. Currently we don't want this. Let's press OK. You can see over here, current stage of version 2 is staging. Let's click over here, register models. You can see over here, latest version 2, version 2 in staging stage and version 1 in production. Again, let's click on version 2. Now we assume that our version 2 of our model has passed every stage of testing. So we have to move it to production. Let's click over here. Now please concentrate. Now here we have to keep this tick as it is because transition existing production model versions to archived. We want version 1 inside archived and version 2 in production. So let's keep this tick as it is. Let's click OK. You can see over here, version 2 in production. Let's check. Let's click register models. You can see over here, version 2 in production. Let's click over here and you can see version 1 in archived and version 2 inside production. Now hope you can understand that we have discussed over here model lifecycle, development, staging, production and archived, right? The question is why to archive previous models, and here is the reasons. First, for reference, checking past models for insights. Second, compliance, meeting regularity and auditing requirements. Third, reproducibility, reproducing results or understanding past predictions. So for that, we can use archived models. Also for rollbacks, switching back to previous versions if needed, and also for future use, reusing models for future projects. That's why we are putting previous versions of the models in archived. Hope all of you are clear with this. Let's back over here, and you can see version 1 in archived and version 2 in production. I hope you can now feel how machine learning project management is done in the industry, right? So now MLOps engineer can take this particular model which is currently in production for deployment purpose. Now let's move on. So after some time, if there are any performance or other issues, the same cycle will be followed for version 2 as well, right? Now you can see how useful the model registry is in the machine learning lifecycle, right? So now let's move on. As we discussed, we can perform all the tasks using code just like we did with GUI. Let me show you how. Let's create version 3 of our model, and we will register our model using code without GUI. So let's move to VS Code. Again, let's perform some changes. Let's save our code, and we want new run to be created. So let's rerun our code. Again, as you know, we have to wait. It will take some time because we are performing hyperparameter tuning. And here we want new run to be created because we are going to create version 3 that we will put in the production, and we will move version 2 to archived that we are going to perform using code without MLflow GUI. Now done. You can see accuracy, precision, recall and F1 score. Now let's consider this is the best model that we want inside production. Now first we have to register this particular model that just we have created. So let's create new Python file with name register.py. You can give any other name as well. So first we have to import MLflow.tracking. We have to import MLflow client. Also we have to import MLflow. Let's save our code. Let's first initialize the MLflow client that we have imported over here. So let's create variable client and MLflow client, right? So now to register the model in the model registry, we have to write like this: MLflow dot register underscore model. And here as an argument, we have to pass model underscore URI and model underscore name. And let's assign it to one variable reg. So now first we require model underscore URI. So we can write model underscore URI like this: app string runs, and here run underscore ID slash model underscore path. So this is the format for model underscore URI. So again we require this run underscore ID. Also we require model underscore path to construct model underscore URI, and here also we require model underscore name. Let's save our file. Let's move to GUI to get run underscore ID, and which is current run. Let's click over here, and this is the run ID. Let's copy this. Let's move to code and let's paste it over here. This is our run ID. Let's save our code. Now we want model path. Again, let's move to GUI models. Let's click over here and here, and this is the model path. Let's copy this by clicking this particular button. You can see copied. Let's move to code and let's paste it over here. Let's save our file. Now we want model name. Again, let's back to GUI. Let's click on the models, and this is our model name. Let's copy this. Let's move to code and let's paste it over here. Please remember, we have to give same model name. If we provide new model name, the new version with 1 will be created, but we want version 3, upgraded version of version 2 of the same model. I think all done. So this way we can register model using code. in MLflow registry that you can see over here. Now let's clear this and let's run this particular file, register.py. Let's execute this code. You can see over here. Created version 3 of model water underscore potability underscore RF. Let's check. You can see over here version 3 has been created. So you can see this way we can register model using code. Let's move to GUI. You can see over here version 3 has been created and stage is none. Means currently this particular version 3 inside development stage. Let's move over here and you can see here latest version 3 and currently model 2 inside production. Hope all of you are clear with this. How to register model using code. Let's move on. So now let me show you how we can change the stage of the model using code. And as you can see currently version 2 in the production and latest version is version 3. Let's click over here and you can see current stage is none, means it is in development stage. Let's move this model to staging first, but not from here with code. Let's move to VS Code. Let's create new file stage.py. You can use any other name as well. So again we require this all. Let's copy this. Let's paste it over here. Let's save our code. Let's define the model name and version. Let's take model name from here and model underscore version is equal to 3, right? And let's assign new stage. Let's move to staging stage. So here we are going to put this particular version 3 inside staging stage. And to do this, again, we have to call this client dot transition underscore model underscore version underscore stage. Here we have to provide all this information, name of the model that we have already provided with model underscore name. This one, version model underscore version 3, stage is equal to new stage. We want this particular stage for model 3. And here is important parameter, archive underscore existing underscore versions. What you want to do with existing version means version 2. Let's set it false at this time and all done. That you can see over here. So this way we can change the stage of the model using code. Let's run this code. Please ignore this particular warning. Let's move to GUI and you can see over here stage has been changed for version 3. Let's click over here registered models. You can see over here now version 3 inside staging stage and 2 inside production. Now let's change the stage of version 3 to production and version 2 to archived. So in place of staging, we have to write production and please concentrate. We have to set this to true because we want to put existing version, which is version 2 inside archive. And we want to put this particular model into production, version 3. Let's clear this and let's run this file. All done. Let's move to GUI. Let's refresh this and you can see over here version 3 is in production. Let's click over here. You can see version 1 and version 2 both are in archived stage and version 3 in production. Hope all of you are clear with this. I think now you feel how machine learning project management is done in the industry, right? So now currently this particular model version 3 in the production. Now MLOps engineer will take over this model which is inside production and start deployment related task. Lastly, let's understand a very important point. As per our workflow, model version 3 is in production, right? So the question is, why are we doing all this? The answer is to ensure we use the best model, right? And this is our best model version 3. Now let me show you how we can perform predictions using this model. This means we are going to fetch the model that is currently in production, version 3. In our case, we can then create an application or an API that uses this particular model. But now let me show you how to do this in a simple way. So let's move to code and let's create new file with name prediction.py. You can give any other name as well. So first let's import MLflow.py func. Also we have to import pandas as PD and also we have to import MLflow. Let's save our file and let's set tracking URI HTTP 127.0.1 5000 port number. Let's save our file and here I have created this particular data frame for prediction with these values of pH, hardness, solids, etc. Save our file and let's move to our GUI. Let's click over here version 3. Let's click on experiments and this is the model. Let's move to artifacts and here you can see the code for making predictions is already provided. You can see predict on a pandas data frame, also predict on a Spark data frame. But currently we are using pandas data frame. So let's copy this code that you can take from artifacts, right? Let's move to our code and let's paste it over here. Let's remove this because we have already imported this. Also we have imported pandas as well. Let's save our code and don't forget to print the result. As you know, this is the binary classification problem. Output will be 1 or 0. 1 means water is potable. 0 means water is not potable. Let's clear this. Let's run this file. You can see over here output is 0. So as per this particular sample of the water, water is not potable, that you can see over here. So this way we can perform prediction. Hope all of you are clear with this, right? I hope all of you are clear with this workflow of how the ML model lifecycle often works in industry, like model development, model registration, model deployment, and monitoring and retraining. And I'm sure all of you are clear with different stages of model. In MLflow, models go through different stages to manage their lifecycle effectively, like this: development, staging means testing, production, and archived. I'm sure all of you are clear with this. All of you are clear with how machine learning project management is done in the industry. Hope all of you are clear with this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.